Is your goal to get an A grade in the topic decimals? In my years as a math teacher, the best strategy is to work through and complete challenge questions in your study. In this video, I'll explain how I attempt 3 different challenge questions so that you could feel more confident answering these in your exam. I'll be picking questions from any lesson in the decimals topic. Before watching this video, please check if you know all the skills from the following lessons. If you need to revise any knowledge, I'll leave a link to my decimals playlist in the description. Let's jump into it. I'll be using the RISN problem-solving acronym to help solve these questions. The R, which is the first step, is to read the question carefully. So example 1, Sam was adding decimals on a calculator. Instead of adding 42.95, he added 42.095. What should Sam do in order to correct his mistake with only one step? The next I, the second step, is to identify the maths topics and lesson that may be needed to solve the question. This helps you recall any key facts or procedures that could be used to help solve the question. This is from the decimals topic, using the skills from the lesson ordering decimals and adding and subtracting decimals. If it is not clear which topic and lesson is needed for this question, move on to the next step because it may reveal itself later. Next, the S, the third step. Summarize key information and set up the question. At times, using diagrams or illustrations can help. So if we make a number line for both scenarios, if this is 42.95, and this would be 42.095. Now to fix the mistake with one step, we could add the remaining value that reaches 42.95. Remember, we use letters in maths to represent unknown numbers. Next, the E, the fourth step, which is evaluate, which in other words is find the answer. To solve this question, if we subtract the smaller number 42.095 from the larger number 42.95, we'll be left with the unknown x. So subtracting the rightmost column first, we can't do. So we borrow from the next column. Now completing 10 minus 5, which is 5. Moving on to the next column, again we can't do. So we borrow from the next column, now completing 14 minus 9, which is 5. Moving to the next column, completing 8 minus 0, which is 8. Then adding the decimal point to our answer, then subtracting the whole numbers. We notice if we consider both columns at the same time, this is just 42 minus 42, which is 0, giving us an answer of 0.855. Next, the N, the final step, which is now check your answer. We can do this by adding our answer and 42.095 and see if it equals 42.95. And yes, we know we are correct. Example 2. A farmer has a rectangular paddock. The height of this paddock is 1.4 kilometers and the base is 2.73 kilometers. What is the area of the paddock rounded correct to 1 decimal place? This is using the skills from 2 topics, decimals and area, from lessons multiplying decimals, rounding decimals, and finding the area of a rectangle. Next, summarizing the key information with a diagram. Then recalling the area of a rectangle formula, which is base times height. Therefore, to set up the question, we need to multiply the base, 2.73, by the height, 1.4. Now evaluating. We set up the question without the decimal point. Then we start multiplying this column, 4 times 3, which equals 12. We write down the last digit, then carry the 1. Next, multiplying 4 times 7, which equals 28. Then we add the extra 1, giving us 29. Then multiplying 4 times 2, which equals 8. Then we add the extra 2, which is 10. Next, we multiply the tens column, the 1. Before we start, we add a 0 to the next row. Now multiplying each column. 1 times 3 equals 3. Then 1 times 7 equals 7. Next, 1 times 2 equals 2. Finally, we add these two results, taking our time adding each column. We get 3,822. Finally, we need to place the decimal point in the correct location. Since the question has a total of 3 decimal places, the answer should also have 3 decimal places, giving us an area of 3.822. Remember, we need to round to 1 decimal place. 8 is our target digit. We check the digit straight after. It is lower than 5, so our target digit remains the same, giving us an area of 3.8 kilometer squares. Now, checking our answer, we can do this by rounding our original measurements to whole numbers and see if our answer is close to this, which it is. Awesome. Example 3. Sarah is climbing Mount Kosciuszko at a constant rate. At 2 p.m., she was 0.2 of the way up. At 4 p.m., she was 0.75 of the way up. At 3 p.m., how far has she climbed up the mountain, written as a decimal? First, let's take a moment to try identify the topics and lessons that could be used. We can see that we'll be looking at the topics decimals and time, using the skills in the lessons adding and subtracting decimals and dividing decimals. Next, summarizing the information with a diagram. So we need to find the distance at 3 p.m., which is exactly half the distance between 0.2 and 0.75, since she is traveling at a constant rate. To find the distance at 3 p.m., we first consider the distance traveled up to 2 p.m., which is 0.2. Then we add the exactly half distance between 0.75 and 0.2. Let's first write 0.2 as a decimal 0.20, so we are subtracting decimals with the same number of decimal places. Now let's evaluate the distance between 2 p.m. and 4 p.m., which is the difference between 0.75 and 0.2. We can solve this either by setting up the question and subtracting each column, or by recognizing that this is 75 out of 100 minus 20 out of 100. So you'll be left with 55 out of 100, which is 0.55. Now we need to halve this distance. In other words, divide by 2. The best way to evaluate this is setting up the question in short division form. First asking how many 2's go into 0, which is 0. Then we add the decimal point to our answer. Next asking how many 2's go into 5, which is 2 with the remainder 1. We carry the remainder to the next digit. Then asking how many 2's go into 15, which is 7 remainder 1. Since we'll get a remainder, we need to add a 0 to complete the calculation. Don't forget to carry the remainder 1. Next asking how many 2's go into 10, which is 5, giving us an answer of 0.275. Finally, we need to add 0.2 plus 0.275. Make the addition easier by making both out of 3 decimal places. In other words, thousandths. So now we're adding 200 out of 1,000 plus 275 out of 1,000. We will have 475 out of 1,000, or 0.475. Now to check our answer. There may be times where this is impossible. However, you can check your answer and see if it is reasonable, especially in a real-world example. And the value we got is larger than 0.2 and lower than 0.75. So yeah, it is reasonable. You now know how to answer A-grade questions. But are you curious why you learnt the decimals topic to begin with? Watch this next video to learn why you need this in maths and where it could be used in the real world.